you can compare, contrast the difference. Okay. So on the left hand side, we are going to determine IYY. Okay. And the right hand side later on we determine IZZ. So we know our axis. Okay, we know our transformation. So this is our transformation. This is our Y, and this is our Z. Okay. So we are going to focus on IYY. IYY means second moment of area about the YY axis. Okay. So I'm going to draw the green line, which is our interest, our axis of interest. Okay. So this is our YY line. When that's the case, when there's our YY line, the line that is parallel to the axis of interest, this will be equal to the width. Okay, easy way to remember this. And any geometry, okay, that's perpendicular, right? This is perpendicular to the axis. This is our depth. Okay, that's all you need to remember. Are we clear? Okay, that's all we need to remember. Okay, so now we want to calculate our second moment of area. Okay, so I'm going to divide this into section 1. The center part is our section 2. The third part is our section 3. Okay, so we know that IYY 1 is equal for 1 will be equal to IYY 2. Okay, so the formula is width. So IYY, what is our width is 9.5, right? Our depth is what, 80, because 40, 40, 80 cube over 12. And then we have the 9.5 multiplied by 80. And this is equal over here 0, because why this is 0, because the global or the entire structure and individual section centroid are on the green line. Okay, the green line I draw, the individual centroid and the global centroid are in the same position, so it's equal to 0. So immediately from here, we can formulate that this will be equal to 9.5 times by 80 power 9.5 times by 80 power 3 divided by 12 is equal to 405.333 times 10 to the power 3, and this will be in millimeter to the power 4. Then the next thing we do is we want to find IY of, sorry, this is 1 and 3. Okay. And then IY2. So the width will be 120. The depth is 9.5 cube over 12, and then plus by 120 times by 9.5 again is equal to 0, because the global centroid and the individual centroid are the same. So this will be equal to 120 times by 9.5 power 3 divided by 12 is equal to 8.574 times 10 to the power 3 millimeter 4. So therefore, Iy will be twice of Iy1 plus by Iy2. Okay, so the twice multiplied by 405.333 times 10 to the power 3 plus by 8.574 times 10 to the power 3. Okay, so this will give us 2 times 4.05.333 power 3 plus by 8.574 power 3 will give us 819.24 times 10 to the power 3 millimeter 4, or 8.19.2, or 8.19, 819.24 times 10 to the power minus 9 meter 4. Okay. So as you can see, the most important thing to identify now is where is the axis of interest. After you have defined the axis of interest, the geometry that are parallel to the axis of interest is our width. The geometry that's perpendicular to the axis of interest is always our depth. Okay. So the one on the right now, okay, so we look on the one on the right. Okay. So now we want to determine what is our IZZ, right? We want to determine what is our IZZ. So from here, I'm going to sketch our ZZ axis. Okay. So this is our ZZ axis. Apply exactly the same concept I've just taught. Anything that when the geometry that is parallel to the axis of interest, this is our width. Anything that is perpendicular, this is our depth. Right? You can see that over here, this is 90 degrees to our axis of interest. Okay. Always do this. You will never get it wrong. The thing to remember, I'll write down how to remember this. Okay. So if when the geometry is parallel to the axis of interest, okay, this is usually, this is not usually, this is the width. And if the geometry is perpendicular to the axis of interest, this is the depth. Okay. So parallel, width, perpendicular, depth. Okay. So again, I'm going to label this as 1. I'm going to label like before. This is our section 2 and our section 3. Okay. So we are going to find our IZZ. Did I call it double Z? Or okay, IZ1 is equal to IZ3, right? So our width will be 80. Our depth is 9.5. Power 3 divided by 12 plus by 80 multiplied by 9.5. And then now, okay, we have to determine our global centroid. And based on observation, this will be equal to, so this is 60. and that's 9.5. So it's equal to 69.5 times 69.5, and then minus, okay, by 9.5 divided by 2. Why 9.5 divided by 2? Because now I'm going to zoom it in. In section 1, the individual centroid is exactly at the center over here. Yeah, it's exactly over here, exactly at the center. And this geometry from here to here is 9.5 divided by 2. Okay. So that is why, okay, we have 69.5 minus 9.5 divided by 2. So this will be equal to 80 times by 9.5 power 3 divided by 12. Then we have plus 80 times by 9.5 times by bracket 69.5 minus by 9.5 divided by 2 close bracket squared. And you get 3.192, right? Times 10 to the power 6 millimeter to 4. Okay. And then the next one, we have our IZ2. So the width is 9.5. The depth is 120 power 3 divided by 12. And then this term over here, this will be multiplied by 0 because the individual centroid and the global centroid. So if you look at section 2, I'm going to draw in orange and I make it thicker. Okay. The section 2 centroid is also at this bad idea. Okay, is also along this line. Okay, that's why over here you got the 0 over here. Okay, so from here, this will be equal to 9.5 times by 120 power 3 divided by 12. It's equal to 1.368. So we have 1.368 times 10 to the power 6 millimeter 4. So now we can calculate our IZZ, or our IZ will be twice of IZ1 plus by IZ2. Okay, so this will be equal to twice 3.912 times 10 to the power 6 plus by 1.368 times 10 to the power 6. So this is equal to 2 times 3 point plus by 1.368 power 6. So it's equal to, wait, 2 times 3.912 power 6 plus by 1.368 power 6 is equal to, 3.19, 3.192912, hey, 192. I make sure 3.192 times 3.192 power 6 times 2, that's 1.368 power 6 is equal to 7.752 times 10 to the power 6 millimeter 4, or this can be equal to 7.752 times 10 to the power minus 6 meter 4. So now we have two values. Okay, we have two values. We have IY at 8.194 or 8.194.24 times 10 to the power minus 9. And the other one, we have 7.752 times 10 to the power minus 6. Okay, so I'm going to write the next statement. Okay, buckling, or the second moment of area